Now that you know how to do an analysis of a graph that has two endpoints, now we need to talk about a graph that has arrows, which means this graph is going to continue on in both ends infinitely. There isn't going to be an end. So when we do the intervals for this problem, we're not always going to be able to match them up with a number. You can't say anymore for this graph that this ends at 10. Because it has an arrow. This arrow is going to keep going, keep going, keep going forever. And what does forever mean? That means you're going to have to use infinity in your answers this time. If you go to the right forever, you would use positive infinity. If you go to the left forever, you would use negative infinity. If you go up forever, you would use positive infinity again. If you go down forever, you would use negative infinity. It's just like an extension of your number line. These positive numbers count up in this direction. Think of this as like 100 million kajillion. Positive infinity. If you go up forever, those numbers count up. Positive infinity is a million kajillion. This is down in the negatives, which is why this is negative, and left is also negative. So here's negative infinity. We're going to do the same analysis that you did on all those other graphs. We're going to start with domain. Then we're going to talk about the range. We're going to talk about decreasing, increasing, and constant. We're just going to have to use infinities in some of the answers instead. The domain starts on the left and goes to the right. The left side of this graph is an arrow, so you can't match it straight up with -5 anymore. You match it up with negative infinity. So I'm going to start the answer with negative infinity. I am not going to put an equal bar with it because it can't be equal to infinity. It's not a point. So every time you use infinity, no equal bar. Less than. On the right, you can't match up with 10 anymore. You're going to match up with positive infinity. The range is the lowest point to the highest point. The lowest point here is not a number, it's an arrow. There's not a point there. So we're going to have to match that up with negative infinity since it's on the bottom. Less than. Remember your y this time. Less than. Now let's look at the highest point. That is not an arrow. That is a finite point. This is at +5 on the y-axis. So in the range, we're going to have a regular number just like before. And we're going to put an equal bar on that because there's no open circle. It's a normal number. Decreasing, I'm going to erase that now. We don't need that anymore. Decreasing is a section of the graph from here to here. 0 to 3. There aren't open circles on either ends. There aren't any arrows. So that's a normal looking interval. 0 to 3. Increasing is this side of the graph. This is going up. The left side is an arrow, so you can't match that up with a number. You match it up with negative infinity. Less than x, less than. Now look at the right side. That's not an arrow, that's a point. So we match that straight down to 0, and we put an equal bar with it because it's a normal number. Constant is the last answer. Start on the left and go to the right. The left side here is going to match up with +3. And the right side, we can't match down with this number because it's an arrow, so we match it up with infinity instead. When you do a graph analysis that has arrows on it, you should have an infinity symbol, positive or negative, in almost every answer. If you don't, you need to go back, look at those arrows. Did you match them up with the point or did you match it up with the infinity like you were supposed to? You go back and look at that. Now that you've done that, I want you on your worksheet to try this problem while you're waiting on me, but scribble out the range The first infinity problem I want you to try, I don't want you to worry about the range. Remember, domain is going to be from the left all the way to the right. And then these three are going to be your sections. You're going to write a negative infinity on this side and a positive infinity on this side. Now turn your cup to yellow so I know that you are trying to do this problem, and I will come and sit with you as soon as I can.